Ever wondered how robots mimic human actions or even outperform us in certain tasks? Welcome to the world of robotics engineering, an ever-evolving field that shapes our future and pushes the boundaries of what machines can do. Robotics engineering is an interdisciplinary field that combines elements of mechanical engineering, electrical engineering, and computer science to create robots. Robots, in turn, are used in a myriad of sectors from healthcare to manufacturing. Picture a robotic arm in a car assembly line, performing precise movements at high speed, or a medical robot conducting a delicate surgery with unparalleled precision. These are just a few examples of how robotics engineering benefits society. In a world where technology is advancing at breakneck speed, robotics engineering is more relevant than ever. It's an exciting, dynamic field that's continually evolving, and its applications are only limited by our imagination. Now that we understand what robotics engineering is, we can delve deeper into its fascinating components. What makes a robot tick? What are the fundamental principles that govern their operation? Well, let's dive right in and explore the core concepts of robotics engineering. At the heart of robotics engineering is robot design. This involves creating a physical structure that can move and interact with its environment. The design process is much like putting together an intricate puzzle, where each component plays a crucial role. From the tiny sensors that provide data about the surroundings, to the powerful motors that propel the robot, every part must work in harmony. Then there's control systems, the brain behind the brawn. These systems interpret data from sensors, make decisions, and send signals to the robot's motors. They're a bit like a maestro, conducting an orchestra of components to perform a symphony of actions. For instance, if a robot detects an obstacle, the control system processes this information and instructs the motors to change direction. Of course, it's not just about hardware. Programming is another key concept. This is where the robot's actions are defined and refined. Think of it like choreographing a dance routine. Each step, each movement is carefully planned and sequenced to achieve a desired outcome. Programming gives the robot the ability to perform complex tasks, like assembling a car or navigating a maze. These concepts are not just theoretical, they're applied in different types of robots. For example, a drone uses sensors to avoid obstacles and maintain altitude, while a robotic arm uses motors and control systems to carry out precise movements. And of course, both rely on programming to execute their tasks. So there you have it, the core concepts of robotics engineering: design, control systems, and programming. Three interconnected elements that work together to create a robot's ability to interact with its environment and perform tasks. They're like the three musketeers of robotics, inseparable and equally important. Understanding these core concepts provides a solid foundation for anyone interested in robotics engineering. But how do we put these concepts into practice? Well, that's a story for another day. Stay tuned. So, how do we go about building a robot? What are the steps involved? Well, it's not as daunting as it might initially seem. We just need to follow a series of steps. Firstly, we need to choose the right materials. Depending on the type of robot you want to build, your materials may range from simple cardboard and glue for a basic prototype to metal and plastic for a more advanced model. Remember, the key is to keep it simple and functional. Once we have our materials, we move to the design phase. This is where we lay out our vision for the robot. We sketch our design, keeping in mind the practicality and functionality of the robot. This step requires a bit of creativity and a lot of practical thinking. Next, we get our hands dirty with the assembly. This is where we bring our design to life, connecting all the parts together. It's like solving a complex puzzle where every piece has a specific place and purpose. After assembly comes the programming. This is when we breathe life into our robot, writing codes that dictate how it should behave. This step requires a good understanding of coding languages like Python or C++. Lastly, we test our robot and refine its functions. This step involves a lot of trial and error, but it's where we get to see our creation in action, making all the hard work worthwhile. Building a robot can be a challenging yet rewarding experience, offering a practical application of the principles of robotics engineering. Robotics engineering is a vast and exciting field with endless possibilities. We've journeyed through its core concepts, discovering how it combines mechanical, electronic, and computer engineering. We've also delved into the nitty-gritty of building a robot, understanding how intricate each step is. Remember, it's not just about constructing a machine, but creating a system that can interact with its environment. As we continue to push the boundaries of technology, who knows what incredible feats of engineering we'll see in the world of robotics in the future.